So last time we saw how to calculate the derivative by using this first principles method. But I'm sure you noticed that the method is actually quite long. It takes a while to do. So what we're going to look at first today is special rules that will allow us to get to the answer quickly. Okay, so let's start. Firstly, we'd like to know, is there any quick way to do problems like this, x power n? Or right, fx actually. So last week, which ones did we do? I think we did x squared maybe, and x cubed as some examples. So let's calculate the derivative here by using our first principles method. If you remember, the formula is fx plus h minus fx all over h. So here, that's x plus h power n minus x power n all over h. So we use Pascal's triangle, which is normal for these problems, and we get not Pascal's triangle, the binomial theorem. nc0 xn plus nc1 xn minus 1 h plus nc2 xn minus 2 h squared etc. minus, and then finally xn at the end all over h. So we can split this up. We have, and by the way, what's nc0? 1. So look, we have an xn at the start and a minus xn at the end, so this will cancel with this. So we're left with nc1 xn minus 1 h over h plus nc2 xn minus 2 h squared over h plus etc. over h. So again, these h's cancel, which is nice. So we have nc1 xn minus 1 plus nc2 xn minus 2 h, because this cancels with the square. And we'll have more pieces here, so I'll just write etc. And just so you know, the next term here will actually have a h cubed in it, because we go h squared, h cubed. So when you cancel it, you're left with a h squared. In other words, what I'm trying to say is, these pieces at the end, which I didn't bother to write, they'll have h in them as well, just like this piece here. That's important for the next bit, because what happens to the value of h now? It goes to 0. So if h goes to 0, then what will happen to this piece? It's gone. And then this piece here is gone. So you're actually just left with this. nc1 xn minus 1. Yeah, now we have to deal with the nc1. So we need to remember the definition of nc1. It's n factorial over 1 factorial n minus 1 factorial xn minus 1. 1 factorial is just 1, so we'll forget about that. So on the top we'll have n minus 1, n minus 2, n minus 3, and so on, all the way down to 1. Then on the bottom we have n minus 1, n minus 2, n minus 3, all the way down to 1. So that cancels, that cancels, that cancels, that cancels, that cancels, and you see that you're just left with an n. So now we have xn minus 1. So we get our result. We have if y equals x power n, then the derivative, the first derivative is, oh sorry, I didn't write my n here, n x n minus 1. And what was the first example I did with you last time with using first principles? Was it x squared? It was x squared, yeah?
Why did we cross the h and the n?
Why do we cross it?
Yeah.
Because at this step we make h go to 0. That's right. So it's gone. Okay, the example I did with you, my first example was x squared. So let's use this formula. If I say y equals x squared, then what we do, notice we put the power in front. What's the power here? 2. And then we remove 1 from the power. So if I take 1 away from 2, if I make it 1 smaller, what am I left with? Yeah, just x1, which is just 2x. And what was the answer we got? What was my next example? What was my second example I did with you after that? It was cubed, was it? So if I have y equals x cubed, then if I use this formula, I have 3x squared. And what was the answer I got? 3x squared. So this formula is a very quick, it gives you a quick way to calculate derivatives without the need to use first principles each time. In fact, there are many formulas for many different types of problems. I won't do the proof for all of them, I'll just do it for this one. But I'll give you a table now, a table which you'll have in the exam, and it's a table of all these formulas. Okay, so can I scroll down? Yeah? So the table, first here is the y, and then here is the derivative. So our first rule we have is xn. Its derivative is nxn minus 1. So that's our first rule. And then we have sine x. Its derivative is cos x. Then we have cos x. Its derivative is minus sine x. Yeah, tricked you. Next then, we have e to the power of something like ax. Its derivative is ax. Then we have log x. Its derivative is 1 over x. Then we have tan x. Its derivative is 1 over cos squared x. Yes. That's all our main functions, aren't they? I mean, we've done sine, cos, e, log, we've done sine, cos, tan recently. Before that we did e and log. And then at the start of the year we did x with a power, quadratic, cubic, so on.
What about EX?
Yeah, so in that case then it's just like the a is 1, so EX would be EX, because the A's would be 1. Yeah. I'm just trying to write it how it is in the formula book. It will look something like this. Okay. So I'll give you an example. Once you have this table written down, we'll do some examples of using this table. Okay. Do you have this table? Yes? Okay. Let's have a look at some examples. So my first example we'll say is a quadratic. We'll say something like x squared plus x plus 1. So which rule will I need to use on my table? 1, 2, 3, 4, 5 or 6? Just the first one. So what we need to do is change all of these into powers. So this is y equals x squared plus x power 1 here, and then what would this be as an x with power? 0. Now we can use our first rule. dy dx, the derivative, equals 2x1 plus 1x0 plus 0x minus 1. But you don't care about this one because it's 0. And what's x to the power of 0? It's 1. And what's x to the power of 1? X. So the answer is 2x plus 1. Let's have a look at another example now. Let's say I have y equals 3x squared plus 2x plus 4. So again, we change this into powers. This is 3x squared plus 2x1 plus 4x0. So the derivative, yeah, the 3 multiplies the 2. So it's 6x plus 2x, well, sorry, 6x1 plus 2x0 plus, yeah, it'd be 0x minus 1 because 4 multiplies 0. This is gone. And what's this here? 2. And this one here? 6x. So the derivative is given by this. By the way, if you want a quick shorthand, you don't have to write dy dx. If you like, you can just write this, y with a little dash. That means the same thing. It's just a short way of writing it. So they're the same thing. Okay, let me give you one to try, and then I'll do it. So let's say y equals x cubed, 2x cubed plus 3x squared plus 4x plus 5. So you try this one for me. So actually, yeah, I'll write it down. So first, I want you to find dy dx, and then secondly, I want you to find dy dx when x equals 1. So there's 2 parts here. So for the people who have done this before, this should be no problem. Okay, let's have a look here. Shouldn't take you too long to do. So, what do we have first for 2x cubed? 6x squared. And then next, 6x plus, that's a 4 by the way. Plus 4. Oh, this, did you do 4 plus 5? There's possibly a 0 at the end. You forgot the 0 again? Yeah. Okay, did you get that? Then for the next part, what's the only difference for the next part? Substitute x is 1. So you have 6, 1 squared, plus 6, 1 plus 4. So that's 16. Okay, let me give you one that's a little bit more difficult. You can try this for me. Yeah.
Why did we cross the line? It doesn't have x.
Yeah, it's gone. There's no 5 here.
Yeah.
Yeah.
But we don't have x, so multiply by 0.
5 is 0.
Yeah, I didn't. Yeah, I agree with you. I didn't write 5 here. This is a 4.
Yeah.
This is gone. There's no x in it. Yeah.
Because there is no x in it.
Ah, yeah, well, basically because there's like an x0, and when the 0 comes down, it's gone. But the way you said it is also right. If it doesn't have an x in it, then it goes. It happened in the last one as well. You see, the 4 became a 0, and then the one before it, the one here, that became a 0 also. So you're right, no x, no derivative, it's gone. Okay, let me give you another one to try that's a little bit more difficult. Let's say we have square root x, no, let's make it a bit more difficult. 1 over square root x plus 2e3x. Try this for me. And then we have 3 more classes, because we have class double, we have 2 classes on Friday, and then 1 class on Wednesday and Thursday. No maths. Yeah? You want this for maths? I'll do it maths next week. So we go to these 3, and then there's 2 more. You're missing the last page. You are missing the last page. You'll need to get that. Okay, are we nearly finished this one? Are we nearly finished this one? Yeah, so let's have a look at it. The trick here is actually to change this into x power minus a half. Yeah. You're all much smarter than I think. Quite good actually. So we change this into minus a half. So the rule is we bring the power down like this, and then we remove 1. We take 1 from the power. So minus a half minus 1? Minus 3 over 2. And then here the 3 comes down, so it'll be 6e3x. Now be careful, some people by accident maybe will write 2x or something like this. But if we go back to the rule here, look carefully, it stays the same. Okay, so just be careful with that. Yeah, so that's the answer. Okay, so there's just one more type I want to do. Then I'll let you try some for a few minutes. I can go down? Yeah. So suppose I give you y equals 3x plus 1, and I would like you to find dy dx, and then dx dy. Now, what does dy dx mean? Remind me, what is the meaning of dy dx? Yeah, what is it to do?
That's the plus.
Oh, hang on. What did you say, Precious? No, that's the next thing.
No?
Slope of what?
Tangent.
Slope of the tangent. So it's the slope of the tangent where we put y here and x here. So then, what do you think the x dy is?
Delta F.
Yeah.
Delta y is out of delta F.
Yeah, so what is the opposite though? Well, the x dy, if you think about it, all that's happened here is we replaced the x with a y and a y with an x. So if you draw the graph this way around, x here, y here, and then x here, then it's the slope of the tangent, but with the axes the wrong way around. Which doesn't make too much sense, but I suppose my real question is, do you think that this is the same thing as 1 over dy dx? You say that with too much confidence, like maybe you don't fully understand or you're just confident. And the answer is yes. And I want to show you two different ways to do this problem. The first part is easy. What is dy dx here? It's just going to be 3, isn't it? So then that makes us think the x dy should be 1 over 3. But is there any way to check this? And the answer is yes, because what we can do is, like I said, we can put the y here and the x here, which means instead of having y equals, we should have x equals. So, if I have y equals 3x plus 1, that means y minus 1 equals 3x. So then what does x equal? It'd be y minus 1 over 3. Or in other words, x equals 1 over 3y minus 1 over 3. So it's like the x and the y have swapped places. The x is now doing the y's job and the y is now doing the x's job. So then dx dy, just like dy dx, except the x and the y have swapped their places, their roles, their jobs. So the 1 over 3, Ali, as you said, this is gone because there's no y in it now. So then what's the derivative of 1 over 3y? It's just like 1 over 3x. What will it be? 1 over 3. Does that answer look familiar?
Yes.
Yes. So I'm just saying there's actually two ways to do it. Which way is quicker? The first way. But I just want you to know that the second way is a valid way to do it as well. Longer, more difficult, but still valid. Valid means good, correct, acceptable. So this lesson really is all about just using that table I gave you. That's all that it's about. Simple, but important for the exam because, I mean, you know, this is in Section A and Section B every year. And it's not so difficult, you just have to use the tables. But if you don't practice using the tables, then you'll make a mistake. Okay, so let's have a look at the questions here. Definitely all of question 1, because they're very short to do. For example, what's the answer for 1A? 56 x power 7. How long did it take you to do that, Boo? 2 to 3 seconds. So you can definitely do all of number 1. But at number 2, you can just go A to I. A to I. And number 3, A to D. Oh, just before you start, there's one more example I want you to do. It's kind of an interesting one with log. Look up, please. It's, what is it, A to I and A to D, isn't it? Yeah. So look up here. Suppose I have y equals, let's say, 6 6x2, and I want the derivative here, y equals log 6x squared. Which rule do I need to use? The log rule. But I can't use it, because what's my log rule for? It's only for log x. Do I have log x? No. So what do we have to do, Lena? What do you think?
Do we do the first rule, apply the first rule for the x?
Nope, not that. I taught you how to there. Change it how?
Log this one x.
2 by 6.
No, that's what she just said. No, not this. You have to use your rules of logs to simplify it first. So the first rule of log is log AB is log A plus log B. So this will be log 6 plus log x squared. Then the fourth rule of logs, what does that let me do with the power? You can do what with this power? Put it in front. Now look what we've done. We've made it so it's log x. What is the derivative of log 6? 0. Why is it 0? There's no x in it. What's the derivative of log x? 1 over x. So it'll just be 2 over x because the 2 is multiplying. So the answer is actually 2 over x. The most common mistake in the exam, which really annoys me, is that students say the answer is 1 over 6x squared. Because they think, alright, log x, its derivative is 1 over x, so then log 6x squared, its derivative is 1 over 6x squared. No. It's not as simple as that. So the answer is actually 2 over x, and this is the reason why. I've seen this in this type of question in the exam twice recently. One of them by me. So you can try these now for a few minutes. That's not right. Yeah, 10 minutes maximum. And while you're trying these, I'll print out those trigonometry graphs for you as well.